Welcome students. In today's class, we are going to discuss about the concept of work done, work not done, and the ability of work done, which is the energy. Before knowing about what is an work done called, we need to see what makes an work done. It is applying some force. Now the applied force can be in two types. Either it can be a pushing force or it can be a pulling force. So any pushing or pulling force can be called as a force. So in the first picture we are pushing a car. Then in the second picture we are pulling a cart. Then in the third picture we are pulling a rope. In the fourth picture we are pushing a vegetable cart. In the fifth picture, we are pulling a suitcase, and in the last picture, we are pushing a wheelchair. All of these are examples of force applied. Applying merely force on something or some object does not mean that work has been done. For an work to be done, that applied force on that object should make the object move from the initial position to a new position in the direction of the force. So there should be change in position or displacement in the applied object in the direction of the force for an work to be done. So in the first picture we can see that a man is pushing a box and he is applying the pushing force from the right hand side to the left hand side. So the work is only done when the box moves from the right hand side position to the left hand side position, which is the direction of the application of the force, or the box moves from position A to position B. Now in the second picture we can see that in a school football match, whenever a boy hits the ball to dodge another player, so he is applying the pushing force on the ball with his leg in the direction, and in that direction only the ball is moving. So here also some work is done. Application of force may not even result into some work done. What are some instances? See, in the first picture, the girl is actually pushing against a wall, but the wall is not moving from its place to some other place, but that is the wall is actually standing in its own place. So even though the girl is putting some force on the wall is not showing any displacement or change in its position. So the girl is applying force, but there is no work done by the girl. Now in the second example, the man is actually pulling up the briefcase in his hand, or he is holding the briefcase in his hand. So the force is applied in the direction of his hand because he is holding the briefcase, but he is standing in a single position and he is not moving. So the displacement or the change in position of the suitcase or the briefcase is zero. So here also the man is not doing any work in physics sense or physical sense. Now if the man moves from first floor to the second floor holding the briefcase, there will be displacement or change in position of the suitcase, and that man will do some work. The next component that we need to learn about is energy. What is energy? Energy is ability to do any work. And energy cannot it cannot be destroyed or it cannot be created. We can just change or transfer the form of energy for every work done. There are some energy giving food as well, which gives us energy, like carbohydrate and fat. The energy is present in this food in chemical form, but whenever we are actually applying that force, applying that energy into doing some work by eating the food, that chemical energy is changed into mechanical energy. There is some energy present in a battery in the chemical form, or the chemical that are present in the battery, and whenever that battery is put inside a torch and the torch is lit up, So the chemical energy of the battery is transformed into light energy. The chemical energy of petrol or diesel is whenever that petrol or diesel is put inside a car and that car is running on that petrol or diesel, so that chemical energy is transformed into mechanical energy. So like this, all of the energy forms are just transforming from one form to another form to do some work. These are some appliances which use the heat energy for doing the work. So there is a toaster. The toaster needs to be connected to an electrical supply, and when we switch on the supply, that electrical energy is going to transform into the heat energy, and that heat is going to toast the breads. So here the transformation of energy is from electrical energy to heat energy. The same is happening in the coffee maker as well. Sun is actually the natural source of our heat energy, and other things that give us heat energy is wood, coal, LPG, etc. Electrical energy examples can be given by so many of you because we know and we use those appliances in our daily life. There is the battery which is actually transformed from chemical to the electrical energy. Then there is the toaster which is transforming the electrical energy to the heat energy. Then there is the vacuum cleaner which is using the electrical energy to mechanical energy. Then there is the phone which uses some charger for it to be used in the later times. So it is also using electrical energy. There is lighting which is also producing electrical energy. An electric eel, eel is a fish which is an animal. They can also produce electric, and that is also a source of electrical energy. Then there is wind turbine which is using the wind energy to produce the electrical energy. So all of these are examples of electrical energy. Next example of energy is the solar energy, and we all know that the source of the solar energy is the sun. And solar energy is a very clean energy because it does not do any kind of environmental pollution because of its use and consumption. So solar energy use of solar energy is actually very much inspired, and every people should use the solar energy for their electric generation purpose, but it's a little bit costly right now. In the left hand side picture, there are the solar cells that have been installed on the roof of the house where there will be plenty of sunlight available. And then the right hand side is an example of the solar cooker which is just placed in the garden, which is having ample source of sunlight, and that cooker is going to cook food by obtaining the energy from the sun. The places which are very empty spaces or large areas or large lands of empty stretchy places, those places with a lot of wind source and lot of windy areas are having these turbines installed, and these turbine fans are going to just get rotated with the flowing wind and the blowing wind, and this rotation is going to change the wind energy into electrical energy. So these are called the wind turbines, which are used in different areas where the wind speed is quite high. Mechanical energy is the energy which is there inside an object due to its motion or due to its position. In the right hand side, we can see there is a picture of the dam, and on the upper part of the dam there is a lot of water stored there. Now that water, for its position in that dam, it is actually having mechanical energy, and when the gates of the dam are open, the water is just pouring down with high velocity in the downward direction, and that direction and that movement and high velocity is used to rotate the turbines to produce electricity. Then it is also having the mechanical energy for its motion as well. In the left hand side picture, an arrow is stretched on a bow, and whenever that man is just stretching that arrow in a bow, that is also having a mechanical energy due to its position, and when the man just leaves the arrow from the bow and that arrow is moving, it is also having mechanical energy for its movement. So mechanical energy can be of two things. One, due to its position of the object, or due to the movement of the object. Next one is the sound energy. Sound energy is produced due to the vibration of the air. Now, if we just take the music system playing, the music system is also vibrating the air that is present around it. Then if someone is playing a guitar is having a hollow space in the middle portion. Every musical instrument has a vacant position which is having air inside it, and the movement of the strings by the man is causing vibration in the air which is present inside that circular position, and that vibration is causing the sound of the guitar. When the rocket is taking off, the rocket is also vibrating the air which is inside or which is outside and surrounding it, and that vibration is causing the sound energy. Alarm clock, man making announcement through a mic or loudspeaker, all of them are causing vibration of the air surrounding it, and that is actually causing the sound energy. And light energy is nothing but the light that we can see. The most natural source of light energy is the sun, and other examples are the light bulbs and the candles. Those are artificial sources of the light energy. The natural source is the sun.